I want to talk to you today about simplifying radicals. There's really two different approaches of doing this. If you can do it the first way, which really is deemed to be the correct way, then it'll end up saving you some time. But some people have a little bit of trouble with that, so I'm going to show you another way of doing it as well. It's a little bit more work, but it's more simplified. So if we're simplifying radicals, the way you want to approach this, you want to think about perfect squares and try to find one that's going to go into our radical. So in this case, we want to look for perfect squares that will go into the number 75. Real quick off the top of our head, thinking about the perfect squares, we've got 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. And really, we don't need any more than that. There's no way any numbers that are higher than these will go into 75. We know that without it being 75. All right, so let's look at these numbers and think about any of them that's going to go into 75. The only one that I see that's going to go into 75 would be 25. And it's going to go in pretty easily, actually. 25 will go into 75 3 times. So what we can do now, we can split our radical up to where it says square root of 25 times 3. It's kind of sloppy. Let me fix that. 25 times 3. If you have this, you can split this up even more, because this is the same as saying square root of 25 times the square root of 3. That's important because you can take the square root of 25. That's the whole point of looking for a perfect square. Square root of 25 is going to be a perfect square, which is 5. So square root of 25 is 5. It comes out to an even square root. And then you just bring down your square root of 3. And that's the answer. That's all there is to it. You do not have to do anything else to that. You are finished at that point. If you can look for perfect squares that will go into the number that's in your radical, it will save you a lot of time. The next way I'm going to show you how to do it is going to work whether you're doing square root, cubed root, fourth root, whatever. And let's just go ahead into it. It's just a skill that we did back in elementary school. It's, elementary and middle school probably. It's just prime factorization. So if I had my number 75, I'm going to break it down to the prime numbers. I'm going to divide it however many times I need to where I get just prime numbers, and then I'll show you what we do with them. So 75, we know that 25 and 3 will go into 75. At this point, if we know our perfect squares, we would know that 25, we'd be able to do all this stuff we just did over here. But let's say we don't. It doesn't matter. We can split that up to where it's 5 and a 5. And the way this works is, now you have the square root of, and you just list your perfect squares. And what happens is, anytime you compare two numbers on the inside of this radical, you can group them and bring them out, because 2 inside equals 1 on the outside. Again, this is only if you don't understand how to do this. This is going to be the easier way using your perfect squares. But if you don't, it doesn't matter. I can say, okay, 5 times 5, I've got 2 of them out there, so I can bring 1 out and leave my square root of 3 in there. Now, if you brought out multiple, let's say there was like another group of numbers over here and you brought those out as well, you'd multiply them together after they got out here. But really, that's all there is to it. It's just showing you 2 different versions. Again, if you can use your perfect squares, do that. Another example. Now we're going to simplify square root of 90. Let's go ahead and think about our perfect squares real quick. We got 2 squared is 4. I'm just going to list them here. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. And again, once you get to this far, 49 times 2 is going to give you 98. So we know that nothing higher than that's going to go into 90. So looking real quick, trying to figure out numbers that go in, the very first thing I see is 9. 9's going to go into 90. It's going to go into 90 evenly. So I can say square root of 9 times 10, which breaks down to square root of 9 times square root of 10. Then I can take the square root of 9, make it 3 times square root of 10. Now, last time I told you, I was like, hey, this is the answer, you're done. And that is the answer, you are done. But you would want to make sure that whatever you had that was out here, you had 3 times square root of 10, you want to make sure that you can't simplify this anymore. So you want to make sure that you're not left with the number that would satisfy one of these perfect squares that you would be able to put a perfect square into again. Because that might not be it. You might have to simplify further. Now, in this case, you can't. 10, none of these numbers are going to go into 10 evenly. So you're done. But if that would have been 3 times the square root of 16 or something left, then it wouldn't be because of this. But let's just say it was 3 times square root of 16, or any number that these would go into, then you'd have to simplify further. We just don't have to right now because that's as far as it goes. But let's go ahead, let's look at the other way. Let's look at our prime factorizations. And I'm still going to use, let's see, I'm going to use 10 and 9 still because that's easy. Well, actually, no. Let's go ahead. I already know it's 10 and 9. Let's use 30 and 3. Let's, for argument's sake, let's say I didn't catch this real quick. So I got 30 and 3. Well, then I'd have to break down the 30 even further, right? So then I'd have 3 and 10. And I break that down to 2 and 5. And it's not going to go any further. So if I did that, then I would have, in my radical, I just list them all out. I'd have 3 times 3 times 2 times 5. Well, I've got 2 3s. That means I can bring 1 out. I have 3 times the square root of 2 times 5. 2 times 5. So then I multiply the 2 and the 5 back together, and I'd have 3 times square root of 10. And that was a crappy circle. That'd be my answer. And then, of course, there was my answer over there. You can see why, if you use your perfect squares, it makes it faster, and it's just a little bit easier, less work. But if you don't know how to do this, there's an out. You can prime factorization this, and there's just a little bit more steps involved. Doesn't really matter to me. I would prefer that you use perfect squares.